All right, this is the beginning of Unit 3 of this course, which is going to be largely about collecting data. Um, I'm going to take this notes just straight from the notes, not do any like additional sketching or drawing or anything like that, because it's really just establishing a whole bunch of vocabulary. So having the right vocabulary is going to matter because these are the terms that are used on the AP exam. So we're going to start with the idea that we have a population, which is the group that we're interested in learning something about, right? So that's the entire group. Um, if you actually measure the entire group, which is pretty rare, but sometimes you can just like, hey, ask everybody in the group the question, or weigh everybody in the group, or measure all their heights, or something like that. Then what you're doing there is taking a census. Usually group sizes and populations are too large to do that, so we tend to step back from that at some point. Um, if we step back from that and we take a portion of the population to examine, we call that taking a sample. So we grab a portion of the population, and then if we somehow study that sample, we call that a sample survey, right? So we're going to collect some data from that portion of the population. The worst possible way to do this, probably, but it's the one that happens quite a bit, is what's called convenience sampling, and that's just literally where you go and you ask the portion of the population that you can easily get to. Okay, so this is literally like going into the lunchroom and say, hey, who thinks this? Or, can I measure you? Or whatever. And that's usually a pretty bad way of doing this. That creates what we call bias, okay? Bias is usually a situation where you have a high probability of either collecting data that overestimates what you want to know or underestimates it, right? So you want a sample to be pretty close to the measurement you would get if you took the census. The further you get from that, the more bias your sample has. Okay. Um, One of the ways that we can create bias is by doing some sort of voluntary response sampling. And unfortunately, this is a pretty common error. It's not uncommon on our campus for students to like send out the Google survey, like, hey, we're doing this, we want to know what you think. And usually the people who have a particular interest in that are the ones that fill in the survey, and then you lose a large group. So if you have a survey that allows people to opt out, you have a voluntary response sampling being done there. And that usually is going to risk some sort of bias in the process. It's pretty close to a convenience sample. It's not as bad, but it's in the same ballpark, right? So what we'd rather have is something that what we call is random sampling. Now, random just means that there's an element of chance in this, and an element of chance means that there's a certain level where um, members of the population have an equal probability of being chosen by your sampling method, right? We get more specific when we talk about a simple random sample. Okay, a simple random sample is that every group of the same size, so it's not just every individual, but like every group of the same size. So like let's say every group of 3 or every group of 9 has an equal probability of being chosen from the sample. This is pretty easy and pretty difficult to achieve all at the same time. Like in theory, it's pretty easy to achieve. Like you take all the names of the people in the population, you put them all in ping pong balls. Okay, you mix up all the ping pong balls and you choose out the sample at random, right? That would be an SRS. But now imagine doing that with like 350 million Americans. Yeah, that's like a box with 350 million ping pong balls. That's just not likely to happen. Um, so doing a simple random sample is attainable in some circumstances, but oftentimes difficult. Um, but it's also not necessarily always the best option. Um, so, for example, if I'm doing an experiment where I'm trying to control against something like age, right? So I'm like testing a COVID vaccine. There you go, and I want to test against age. So what I might do is I might take my population and bracket those into age groups, right? Young, adolescents, young adults, middle-aged, elderly, right? Bracket those into age groups, and those age groups are what I would call strata. They're groups in the population who share characteristics thought to be associated with variables being measured in the study. So, like the groups that I'm creating here share an age bracket, right? So these are my strata. So what I then do is I sample choosing a simple random sample from each strata. So I put all the names of the young people, and then all the names of the adolescents, and then all the names of the young adults, and all the names of the middle-aged people, and all the ages of the into separate buckets. And then I pick out ping pong balls from them. So I take a simple random sample of each of the strata, and then what I get is a stratified sample. And we'll see later on that the advantage of that is I've now controlled my survey against age, right? I know like how does this survey affect particular age groups? Okay, so that's one way of doing this. Strata means that I take some from all. So I create the strata and then I sample each strata. So I'm taking some from all the groups, okay? Cluster is exactly the opposite. Okay, so what I do with a cluster is I take my population and I break them into like groups that are somehow located near each other. Like on our campus, like everybody takes English, right? So we might say each of the clusters is an English class, right? So like you know, Miss Ackerman's nines class might be a cluster, and what do you call it? Miss Miller's AP lit class might be a cluster, right? So those are clusters. And then, so now I've got everybody in a cluster, right? And then what I do is I look at those clusters and I randomly sample those. So instead of like instead of choosing some from each of the strata like I did before, what I do is I say, okay, I have like 17 clusters. I'm going to pick 5 of those clusters, and I'm going to pick them at random. Okay, and then what I'm going to do is I'm going to sample every single member in that cluster. So I've now managed to get some sort of randomness in there. So what I'm going to do there is I'm not doing some from all, but I'm now doing all from some. I'm examining every single member in some of the clusters. Now, my example there with the English classes is probably going to create bias because if I happen to grab like the nines English class and the senior lit class are very different, right? So this is probably not a good example to use cluster sampling with. You pretty much, when you're doing cluster sampling, want the clusters to be all representative of the whole. That you just want them to be like somehow near each other. So that one's probably going to generate some sense of bias there. But we'll look at some places where a cluster could be useful. All right, things that can go wrong with samples. You want to avoid under coverage, okay? So under coverage is pretty hard to avoid. There are going to be some parts of your population who are going to be harder to get to in most cases. Like if you think about, like, I take the population of 350 million Americans, it may be actually harder to reach some of those Americans than others. And then I end up with like undercoverage that's like systematic. So I might find like people who are housing insecure might be harder to reach, or people who are like working during the day might be harder to reach than people who are at home during the day. I mean, so this would cause some sense of undercoverage in my sample. Another way that a sample can go wrong is if there is non-response, right? So, like, one of the classic things when we do sampling of population, especially for like government sampling, is somebody who is an undocumented person in the United States may resist response to that sample because they might jeopardize they're remaining in this country because they're providing information, or I don't know. People who are very concerned about sharing personally identifiable information are people who are not likely to respond to a sample or a survey. So, like, if you are someone who is very concerned that someone is like peeking in on you, this is you're going to find that there's going to be some non-response there. So this is something that could go wrong with the sample. Response bias could be any situation where we're going to get an inaccurate answer to a survey because there's a systematic pattern that's causing that to happen. So there are a lot of different ways to have response biases. Um, Sometimes people are uncomfortable by being asked questions in a public space, so that could cause a response bias, or a particular question might actually, be an uncomfortable question for people to answer on a form. So that could create a response bias. So these are things to be aware of as you're looking at how our sampling and survey is created. So the upshot on all of this is when a census of a population is impractical. Like, we can't go and actually get information on every single member of the population. Statisticians tend to resort to some sort of sampling of the population, taking some smaller group. um, Ideally, they're using some sort of random survey sample to do that, and it's being done in such a way that it reduces bias, ensures coverage, and ultimately avoids non-response. We want a survey that people want to respond to. We want to make sure that we're adequately covering the population, and we want to make sure that we're adequately covering the population in such a way that we're reducing bias. All right, so that's like our intro to collecting data. We're going to be working with this idea of sampling and surveys for the next couple of days, and we'll keep talking about it. All right.